Hi and welcome to part 2. So this time around we're going to start by setting up the coolant tank, and having never done this before, it's going to be an interesting process. I've always been freaked out about coolant that's going to cause corrosion, so I have my hesitation towards this, but with surface grinding it's kind of important. So this one has multiple baffles. It drains into the primary baffle, then overflows into a couple of the others. What I've dropped on the floor here is an aerator I bought for it, because this is going to be water-soluble oil, and water-soluble oil can go rancid if it goes anaerobic, so you want to keep it oxygenated. So I just went on Amazon, bought a cheapo air pump kit. Wasn't very expensive, has a splitter in it so I can put it in both tanks, so that should be good. And we're going to see how that works out. I also got some filtration socks off Amazon that I'm going to fit over this guy. This guy fits through the hole there and then fits down in here. And I got some filtration socks to see if I can keep a lot of the grit out of the tank so I don't have to dredge it. That may or may not work. Over here is where I've got the filtration socks. Normal aquarium filtration socks are about, if I remember right, about 200 micron. This is, I went and looked for 50 micron, and we're going to give this guy a shot. I'm going to have to find some way to attach it on there. Clearly it wasn't designed for this, but hopefully this will fill up, not the tank, and I can just toss these away or clean them out. They aren't very expensive, although I had to buy them in a pack of 50, so that's unfortunate. So if they don't work out, it's going to be a problem. I'm going to have them for a long time. I think they work out to about $2 each. And I think that's it. The coolant I'm using was recommended by Steve Barton over at Solid Rock Machine Shop, and it is a water-soluble oil, Simperial 1070 Blue, SimCool, and it's fairly non-toxic, so that's always a plus. Diluted between 5 and 10%. So we're just going to give this guy a shot. I bought distilled water. Here we are, distilled water, and that's also recommended by the manufacturers and the individuals who have dealt with it. Say that you get bacterial growth a lot slower, and of course you don't have to deal with chemical reactions between all the hard water elements and the other stuff. Plus it'll prevent hard water deposits on things, so that's always a good thing too. All right, so let me get set up here for the aeration first, and I'll bring you right back. So the way this coolant tank is divided, it's got 3 baffles. The return goes in this outer baffle. The lighter materials overflow into the next baffle, which then overflows into the final baffle, which has the pump in it. So what I'm thinking here is that I don't want to put it in the hinged hood if I can, or hinged lid if I can afford it, which I think I can avoid, because they overlap the second baffle with the back plate. So I'm going to drill a small hole, probably in this rear corner here, and what I'll do is I will enter this tank here, put one aeration device in there, one in here, and one in here, and hopefully we will prevent that anaerobic bacterial activity. This was a really good kit. This pump came with all these different adapters and splitters, 2 aeration stones, so that's quite a good deal. I think this is going to work out all right. So we've plumbed all 3 of the 3 baffles with air. I've got air stones in 2 and just a bubbler in the last one, and I was trying to figure out how I was going to attach this guy, but it turns out they have a handy little cloth holder here, and I think the solution is going to be to, hold on one second, let me just clip this guy on here. All right, so now that I've got the carabiner on the cloth filter bag, the 50 micron bag, I'm going to pop the carabiner part through here along with this cloth, and I'm going to try and clip it right here on the handle, which I think might work out great. Then I will stuff the hose down into the middle of the bag, and we'll see how well it works out. I mean, I'm not going to try and get a really tight fit, because if the filter bag clogs immediately, then I want it to be able to overflow. I'm not exactly sure what to expect. I mean, maybe I'll need to use a hose clamp at some point, but we're going to start here and see if this works out. And if I need to, I'll hose clamp the bags onto the drain hose. And here's what it looks like. The hose is down about here, and the filtration bag's still hanging nicely up top. I'm gonna have to undo this because I still have to fill the tank and mix these 10 to 1. I figured I'd go for a 10% solution because I am paranoid about rust. Like, as anyone who's watched my channel knows, and everyone's recommended coolant, I've never been able to pull the trigger because I am so desperately afraid of corrosion. All right, so mixing the coolant, I've just got the spare bucket. I'm going to consider it a perfect cylinder, which I know it's not exactly perfect. It is tapered a little bit. But to get my 10% coolant ratio, I just stuck a ruler in here and marked 9 inches and 10 inches. So I'm going to fill water up to 9 inches. The remaining inch I will fill with coolant, and we'll add it to the tank, and we should be good to go. I probably will need more than one of these because, you know, the problem with the documentation on this guy, they didn't have the documentation for the volume of the coolant tank for this model. They only had the next model up, which included the air filtration along with the coolant, and that one held 13 gallons. I don't think this one's going to hold 13 gallons, but I bought enough distilled water just in case. Anyway, so we're going to do this like 3 gallons at a batch or something like that, 3 or 4, and we'll see where we end up. Alrighty, like I mentioned, I've got the water, you can see, to the bottom line. Now I'm going to fill the remaining with coolant. That was just about 3 gallons. That was a 2.5 gallon container plus maybe a third or a little bit more than a third of the next container. So we're going to fill it with coolant, and then we're going to pour it into the tank. Before I pour the coolant, I'm popping on my safety glasses because although there's no machinery work in here, this coolant is alkali, so and that keeps the bacterial and algal growth down, but that also means it can burn your eyes, so don't forget to wear safety glasses. It's not just water. And here is the coolant mixed. Next time around, I think I'll show you what it looks like. It's kind of nice. It's kind of neat looking. It goes in clear blue or transparent blue, and it gets milky as the oil emulsifies. So we got it mixed in here. All right, so I think we're good to go. I topped it up a little bit. I still got about an inch above the top, so hopefully that'll be okay. And I'm going to lose some evaporation due to wicking up this thing. That's kind of interesting. We'll see when it all works out. And next up, we need a wheel. So we're going to balance a wheel and dress a wheel. And then finally, we're going to start by grinding in the base here. Then we can put the magnet on it, grind the bottom of the magnet, and finally the top of the magnet. That's supposed to be a lengthy process. We will see. I'm kind of excited. All right, so we've got our balancing stand on a surface plate on my bench here, and we have it pretty accurately leveled. By the way, I needed to calibrate this level because it was off, and the only way I'm familiar with doing that is you take the level and you set it on a relatively flat surface so that you get the bubble where you can see it, and you set one side, you put it in one direction, and you look at where the bubble is, then you flip it the other direction, and the bubble should be in the exact same spot. If it's off, then you keep adjusting it till the bubble doesn't move when you spin it 180. Anyways, let's get the wheel on here and see if we can balance it. So we first grab the wheel, we put it on a hub, and I've got it on the balancing spindle, but need to do the tap test and make sure that the wheel doesn't have any dead spots, so in case there's cracks. Then what they recommend is pop it on the stand and let the wheel find its own center of gravity, which at the moment seems like it's pretty close. There we go. Okay, so once you have the center, the low point, you're supposed to mark it on the wheel. Then the next step is to take one of these 3 weights and put it opposite that low point. Once this weight's in place, you're not supposed to move it again. So there it is, roughly across. Take the remaining 2 weights, put them at approximately 120 degrees from each other. Such a fine surface, this thing likes to do the pendulum thing for quite a while. Okay, then it says rotate 90 degrees and move a weight opposite the direction of rotation. So here is 90 degrees, and it most definitely wants to go that way, so I'm going to take this weight and slide it opposite the direction it wanted to go. I am, by the way, not an expert in this, and I am just following the directions. Move it 90 again. And 90 again. My understanding is you continue this process until the wheel stays stable in every quadrant. Again, I am not an expert in this. So I'm just going based on the instructions that came with the wheel balancer. All right, so after screwing around with it, I've got it to stay pretty much in any position I put it. So I'm going to snug down the weights and we should be good to go. If you notice, they aren't exactly 120 degrees apart. Now, all this balancing effort I just went to, the moment I take this over and dress it with the diamond dresser, you have to come back and balance it again if you want it to be balanced. Well, so we've got the grinding wheel mounted. You'll see it there. I haven't dressed it yet. But I just thought I'd give something a test real quick. So Steve Barton over at Solid Rock said that you really do need to grind in your tables. And if you want really, really tight accuracy. So here, this is a 50 millionths indicator. So each one of those little segments is 50 millionths. And it looks like we go 1.5 tenths, or 1.5 10,000ths, oops. 1.5 10,000ths from side to side. And as, that's my up down adjust. As I move in, it stays really steady actually. They did a really good job when they ground this at the factory, I gotta say. Alright, so I got the chuck dialed in so that it's really close. That's only going to be important with the fence, which you're going to grind in anyways, but I want to get close so I didn't have to take too much material off. So now I got to clean up the top of the chuck, and then we got to grind it in, because that really is important. I snugged one tight, just gently tight. The other side is snug. That way, as this thing heats and cools, it'll be able to expand and contract without trying to bow the table. So I've got the diamond dresser not perpendicular, but off at an angle. That way the diamond will wear more evenly, so every time you put it at a slightly different angle. I've got the diamond behind center. In my case, more significantly because I'm kind of clumsy. So we've got it quite a ways this way. If it's on the left of center and the wheel rotates this way, if the magnet were to be not tight enough, not strong enough, it would throw the part off that way rather than here, which would wedge the part underneath the wheel and cause a possible explosion. Alrighty, so I'm going to lower the wheel and just touch. And go at an even pace across, not too slow. And I'll load another 1,000. Definitely a time for safety glasses. It's throwing stuff all over the place. I was told the first time you should take about 10 thousandths off the wheel. I'm doing thousandths passes here. Here's 2 thousandths. Last thousandth. And now I've heard in order to get loose debris off the wheel, you should take a piece of hardwood and run across it to clear any debris on the wheel. Alright, so I've marked up the top with some Sharpie, and I'm just going to try and come down and just ever so lightly touch this thing. Touching off is one of the more challenging parts, I hear. So let's add some coolant here. From my little experience here, other than my terrible touch off, it looks like the thing is really flat already. I will say it is cleaning up the Sharpie all the way across. Completely evenly. So next up, we finished grinding the whole surface of the chuck, and we think we did a pretty good job. I waited till I incremented a 10,000th, and it was an even grinding sound across the whole surface. Hopefully that's correct. Still have a lot to learn, so I'm not sure. So next up, I raised the rear fence, and you can see the relief under it, so that when it's all the way up, I can side wheel the whole fence and get it perpendicular to the table. So that's where we're headed next. So now I've got the dresser behind the wheel, and we're going to try to make really light contact. Okay. All right, so we've trued the wheel on the back side, and now we're going to just run along this guy and see if we can clean it up. And I believe we're good to go. So we used the rear side of the wheel to grind that parallel. Waited till we heard even contact all the way across, and I think that should be right. We'll go from here. Next up will be to do the 5-block test, where we put 5 blocks on the corners in the middle and see how close they are to the same size, and see if we got this thing all square and flat. All right, so here we have 5 pieces of steel, and I've numbered them 1 through 5, and we are going to split them up and put number 1 over here, number 2 over here, number 3 over here, number 4 over here, and number 5 in the middle. Then we're going to turn the magnet on. Oh, these are stainless. These aren't going to work. I'm going to have to go find some steel. I'll be right back. Take 2. I have 5 pieces of steel, and we are going to set them at the 5 edges of this magnetic chuck. 1, 2, 3, 4, 5. And we'll engage the magnetic chuck. Now they're nice and tight. All right, so we have to grind both sides of these because this is hot rolled steel, so it's a mess. So we're going to spin up the grinder and let it come up to temperature for about 5 minutes, and then we'll proceed. Sorry about the jiggle there. We'll be right back. I'm trying to spark off, and I'm coming from the left side again so that in case my part, I go too far down, that it won't eject the part. All right, there we are. Last pass on side 1 at 2/10 depth. Now we're going to take and flip these guys over after we clean off the chuck and go for the other side. This is just the bottom. So here we go with the first pass on the top. I'm going to take kind of a big bite. Then I'm going to redress the wheel. Okay, so I've got my tenths indicator stand here, and I was going to use number 1 as my reference, and I'll do that, but we need to know that I dropped it and it got scratched, and I ran it over my precision ground stones, but it's still not great on the bottom. It got damaged. So I did set this up with this guy at 0. There you go. Okay, so you see that 0. That's block number 1. Here's block number 2. Reads about 1.2 tenths. .1 tenths or 1/10. .1/10. Finally, number 5. About 1.1 to 1.2 tenths. Go back to my original. And it's at 0. And the reason why it's a bit smaller than all the rest is because when I was grinding these and I took them off to flip them over, I didn't notice the scratch and I set it back down with a scratch. So I'd say that my chuck is pretty much flat to within, maybe 20 to 50 millionths. And this block I kind of screwed up on because I didn't notice the burrs till too late. And you can see where the shiny spots here, hopefully, where the precision ground stone caught the high spots. So when I ground it the next time with this side down, it took off just a little bit more material, probably around 1/10. So anyways, that was a really interesting project. I think we're pretty much dialed in here. I'll go back and try this test again just to make sure that one corner of my magnetic chuck isn't off. So here's the surface finish with the 46 grit wheel, and it's surprisingly good. It has some scratches in it already because the dial indicator hardened point, because these are just hot rolled steel, not hardened at all. And so they really didn't appreciate having hardened steel dragged across their surface, even something as smooth as a ball bearing. But all said and done, I think the whole thing is accurate to within less than 1/10, so that's really good. I'm sure I could have done better if I'd followed all of Steve Barton Solid Rock Machining's instructions of grinding in the table first, then the bottom of the chuck, then the top of the chuck. And I didn't do that because this is the first time I've ever used a surface grinder, and I really felt uncomfortable about trying to improve on the factory grind on the table. But if I ever take the chuck off, I will start from scratch. Hopefully I have a lot more experience by then. If you like this video and the ones I do, please subscribe. Always please leave comments below. I love to hear them, and I try and answer them all. I always learn something from the comments, no matter what people say, and I really appreciate them. So thanks for watching. Hope to see you next time.